All right, welcome to our final concept for the measurement unit, tolerance, which means you'll have to tolerate this lesson. Quite a bit of information here, but not particularly complicated. So let's have a look. Tolerance. When designers give dimensions, here's where I want to start. When objects are manufactured, no two will be exactly the same size. This is due to errors in construction that cannot be totally overcome. As a result, designers allow for error, but only to a set limit. The measurements still need to be accurate within a certain degree so that parts fit properly. Tolerance. When designers give dimensions for objects to be built, they know the actual dimensions will not match exactly. The builders come as close as possible to the specified target value, called the nominal value. The limit of error that designers allow in the construction of an object is called the tolerance level. Different situations call for different levels of tolerance. For example, when the wheels are made for a particular type of car, the hole pattern of the wheels must be very similar to the bolt pattern on the vehicle, or the wheel will not fit. When the wheels are constructed, they must be made with a tolerance level of plus or minus 0.001 inches. There cannot be more variation than a thousandth of an inch in this particular situation. The bolts and holes on the wheel of a car. Continuing on page 58, when carpenters built a house, you can't be more than a 1/16 of an inch out, give or take. You can be, as long as it's not more than that, it will not affect the function of the house. If it's any more than that, you can get things like leaks in your roof or cracks in your foundation more easily, little things that will add up over time. Some manufactured goods must be built to a very low level of tolerance. For example, tolerance levels for many aircraft parts are 1/10,000th of an inch, plus or minus 0.0001, 1/10,000th of an inch. The equipment used to manufacture the parts requires a high degree of precision. Tolerance limits. The nominal target value and the tolerance levels are always given by the designer of the object. These tolerance levels will determine the allowable limits of the size of an object. A measurement calls for 8.231 plus or minus 2 thousandths or 0.002. So the maximum limit is 8.231 plus 0.002. And the minimum 8.231 minus 0.002. So every one of these parts manufactured must be between 8.229 and 8.233. They have to be within that range. What are the maximum and minimum limits of a measurement of 92 plus or minus 1/4? Well, 92 plus 1/4 would be 92 1/4. 92 minus 1/4 would be 91 3/4. So minimum 92 1/4, minimum 91 3/4. Let's briefly. So, and your tolerance then is your maximum take away your minimum. 3/4 take away 1/4 is 1/2, so it can't be out by more than 1/2. Let's take, for example, the lumber industry. And you're going to have a wall in a house. That's an 8-foot wall. This wall cannot be out by more than a 1/16 of an inch. So it can be 8 and 1/16 inches at the maximum, and it can be 7 and 15/16 of an inch. So between these two measurements, if it's supposed to be an 8-foot wall, it cannot be out. It has to be somewhere within this range. Okay, that's the basic idea of tolerance, is the range of error that's accepted. Nothing is ever going to be measured perfectly, whether it's done by humans or by machines. It's by robots. Point is, it's never going to be perfect. Now, there's only one way to find tolerance, and that's the upper limit and the lower limit. But as you see here on page 59, there's more than one way of stating it. One way is limit dimensioning. It states the minimum and the maximum. In this case here, 7.75 and 7.79. The example we just looked at, 7 and 5/16 to 8 and 1/16. Between that range. Okay, the upper limit and the lower limit. Or the one in between. The average of the two, in other words. Okay. Looking at plus and minus, that's the one we were looking at earlier, 8.231 plus or minus 0.002. Then you have your minimum limit 0.233 and your maximum and your minimum 8.229. Here we have tolerance levels that might be different. And the upper one is written above and the lower one is written below. So 52.6, the upper limit can be out by 0.3 and the lower limit out by -0.1. Okay. So you need to, this is the number that gets added on, this is the number that gets subtracted. Unilateral tolerance is the same as bilateral, except one dimension always has a tolerance of 0 and the other is stated with a plus or minus sign. So the upper limit is 636, the lower limit and a lower limit of 631. The nominal value is 636. So you have a 0 and a -5. Those are your limits. If you're doing unilateral tolerance level notation, this is one that I don't think is going to come up very much. Better to use this one, and these 1 and 2 are even clearer as well. I don't think we need to worry much about number 4. Now then, let's have a look at some examples here. A 56.0 plus or minus 0.3. So what do? 56 add 0.3 is of course 56.3, and 56 minus 0.3 is 55.7. Okay. Simple as that. Now let's double check. Yeah. Oh, and we can take the difference of these two. 56.3 minus 55.7. 0.6 is the tolerance level. Can't be out by more than 0.6 of an inch or a centimeter or whatever measurement, a millimeter. whatever measurement it is that you're using. B, 5.23 minus 6.34, the lower range and the upper range. And all we have to do here in this case is find the difference, right? 6.34 minus 5.23, 1.111. So this is method 1, this is method 2 of the list that we just went through. Let's have a look at method number 3. 5.3, 0.4 and 5.3, and our upper limit is 0.4, our lower limit is 0.3. So what do? We add the upper limit, 0.4, so that becomes 5.7. We subtract the lower limit, there we have, and just take the difference of the two. So you're always really doing the same thing. As you can tell, you always end up finding the difference between the two. So it's just that there's different ways of writing it out. But you're doing the same math every single time. Last example we're going to do here, D, 3.65 plus 0.07 and the lower limit 0. That's the last one, which was called, what was that called again? Unilateral tolerance. So how do we do this one? 3.65 at 0.07. I'm just feeling lazy, so I'm going to punch that in. 3.72. Lower limit is the 0. Take away 0, you're still going to have 3.65, and you want the difference between the two. 3.72 minus 3.65. So a lot of different ways of doing the same thing, kind of like, you know, different ways of adding and subtracting numbers. Although I think in this case, we could really work with one method and it would serve our purpose quite nicely. But that's just how these things are sometimes. Let's look at example 4 over here. Find the tolerance level and upper and lower limits on the area of the given rectangle. 6 plus or minus 0.5 and 2 plus or minus 0.1 are the length and the width. So if I'm finding area, I'm doing length times width. Now normally I would just do 6 times 2 and I'd be finished, but I can't. 6 add 0.5, 6.5 times 2.1 add 0.1 times 2.1. Let's punch that in. So the upper limit is 13.65. Now we subtract. 6 take away 0.5 is 5.5. 2 minus 0.1. 1.9. .45. So the area of this, the tolerance of this triangle is found, you seem like we've done this a million times already, subtracting the two values. 13.65 minus 10.45. 3.2 would be your tolerance here. Whatever your unit is, centimeters squared, I guess we should throw a unit in here. Could be useful or not, I don't know. I think we're going to skip example 5. We're going to move over and have a look at example 6. The volume of metal that will be required. Well, we're going to come up with two values here. We have an A and a B, and we have a depth of 4.2. I'm simply going to do A. We'll just simplify this. We're going to ignore B. So we're looking at length times width times height. And let's add them first. So 5.7 with a tolerance of 0.1 becomes 5.8, right? 10.5 and 0.1 becomes 10.6. And the depth of 4.2 with a 0.1 tolerance becomes 4.3. So I'm simply doing 5.8 times 10.6 times 4.3. 264.364. Okay, now let's do 5.7 take away 0.1 becomes then 5.6 times 10.4 times 4.3. $250.432. So now I just need the difference of these two numbers, right? $264.364, and this is going to be a different answer than the one they're giving in the example, because they're taking the two. They're going to do this, the B part separately, but we're just going to do this one. 264.364 minus 250.432. 13.392 centimeters cubed, cubic centimeters, is your tolerance level. Now they have a different answer, naturally they do, because they're also doing a little square or subtracting it. They end up with a 28, but that's fine. We get the idea, and we'll move along from here. We'll simply length times width times height. I wanted to keep it a little simpler. Let's have a look at the brain power for today. Brain power. This pattern here is obviously subtracting 6. So we have a 35 and then we have a 29. Reduce this fraction. Say it goes into 2. Divide by 2. 14 divided by 2 is 7. 64 divided by 2 is 32. Okay. 3 times x minus 2 equals 16. Well, if we add 2 to both sides is 18, right? So we're going to have 3x equals 18 because we moved the 2 over to the 16. Therefore, x equals 6. 3 times 6 is 18, minus 2 is 16. A 171 page book has 9 chapters. Assuming each chapter has the same number of pages, how many are there in each chapter? Well, we got to do 9 into 171. I'm going to do long division here. Haven't done that in a bit. 9 times 1 is 9. 17 take away 9 is 8. Bring down the 1 is 81. 9 into 81, of course, goes 9 times. There are 19 pages in each chapter. 6% of 550. Need a calculator. 550 times 0.06. 33. Your homework for this lesson. Page 67 and 68. We'll take a look at it. Just 2 questions. Page 67, number 1, and page 68, number 2. Here we have measurements of tolerance. We're saying that A has a measurement of 1, upper limit 0, lower limit minus 0.1. Okay, so we take the nominal value here. I'll do the first one, couple. A is 1. Okay, the upper limit 1 add 0 is 1. The lower limit 1 take away 0.1 is 0.9, and then the tolerance is 1 take away 0.9. So your tolerance then is 0.1. Let's do B. B is here. B says 1.2 plus or minus 0.1. Nominal value 1.2. Add 0.1 is 1.3. Take away 0.1 is 1.1. And then 1.3 subtract 1.1 will be your nominal value. 0.2. Okay, there's the first couple for number 1, and this is how you do, and it's written in the various ways that it can be written. Number 2 is our other one. Simply find the tolerance of this area. This is 7. Add 0.6, so it's going to become 7.6, and this is going to become 5.72, and then you'll do length times width, and then you'll subtract them and do length times width again. Find the difference of the 2. Okay, just try 1 and 2. Number 1 on page 67, number 2 on page 68, and that will give you enough practice with the concept of tolerance. Our next lesson, so this was not even a 25-minute lesson, nice and short. Next lesson, I will go over the final hand-in assignment for this unit, which begins on page 70. But I'll do that in a separate recording. I won't put it into this one. That will be all for today. So sometime next week, that final assignment will be coming up. So get the homework done. Make sure you have the other assignments done that count for marks. There have been a couple so far. This will be your last one. All right, that's all for this lesson.